everybody, and welcome to this month's Specifying Practice Group webinar. Our topic for today is on floor slab moisture. Keep in mind that for today, our thought leaders are Dave Stutzman and Louis Metcalf. Dave is a registered architect, certified construction specifier, and founding principal of Conspectus, a specifications and quality assurance consulting firm. Louis is an architect, certified construction specifier. Louis manages the specifications and quality assurance programs at Gresham Smith & Partners, a national architecture, engineering, and interiors and planning firm. So with that, I want to hand it over to Dave and Louis to start today's presentation.
Well, good afternoon, everyone. This is Dave coming to you from sunny, beautiful southern New Jersey. Louis?
And this is Louis coming to you from Nashville, where it's pleasantly warm but overcast today.
All right. Well, Louis, I am so glad that you decided to present this program today.
It is to laugh.
And here you have it, uniform approach to concrete floor slab moisture. And I think we're done. I mean, the whole presentation is right there. Everybody can see it.
It's all diagrammed out.
Oh, gosh, we could just go home now. Don't you think?
Well, tell us about what kind of contract requirements does this thing, how does that affect it?
Okay, well, I hope you all enjoy the diagram, first of all, because I'm doing this showing you slab on grade today. And we're not going to really limit the discussion to slab on grade, but we're going to talk about all the concrete slabs. And
we're looking forward to seeing those videos too.
Well, yeah, this is something new that I'm going to try today. So all of you are guinea pigs, and if it doesn't work well, we can blame Louis, and we'll try something different next week or next month. So why don't we go ahead and get started, because I think we're going to have a really nice crowd with us today. We had a lot of interest, and we've had a number of finish flooring manufacturers say that we're going to join us today, and hopefully they are online. And I want to make sure that anybody that's here new understands that we really do want your comments as we go through the presentation. This is a dialogue, not a monologue, and feel free to interrupt Louis at any time. All right. So we want to talk about, I just want to run through some of the things that we know are affecting or contributing to this slab or the concrete moisture problems. One of them has to do with the subgrade, and there's been a number of discussions about this. We need to be looking at that ground slab or the moisture break between the substrate earth and our slab, and we need to be looking at keeping that moisture out of the building, number one, and out of penetrating through the slab into the building, because you all know that.
I learned about that in Boy Scouts at age 11 when they taught us about, because we didn't do camping with my family, but they taught us about the need for a ground cloth underneath your sleeping bag if you're going to sleep on the ground.
Ah, yes, and keep those sleeping bags dry, because if they're not dry, you're no way are you staying warm. So what we're looking for, number one, is that moisture break between the slab and the earth. And I think the industry is pretty well settled on the fact that we're going to use stone, hopefully uniform graded stone, because we want those voids, because that's what's going to stop the water from migrating. So if we use stone that has various gradations, we're going to end up filling all those voids. So we want fairly uniform graded stone. Okay. The next in the level, and let me just slide over here a little bit so that you can see where we're going. So we're talking about the uniform graded stone. We're now going to move up to this vapor barrier, and eventually
sometimes known as a capillary break, because the voids should be large enough that they won't draw water up like very narrow voids would do, like
Correct.
Brick does.
Right, and that's why we want the uniform graded stone, to create those gaps. Okay, so vapor retarder, not barrier, unless you are looking at some very specific products, because there's only a couple. One I know for sure that's actually rated at 0 perms. The others are all rated at some perm rating, so the preferred term is retarder. We're just going to slow the vapor down enough that it doesn't create much of a pressure and cause problems for the flooring. We've got some standards out there that we can rely on for the retarders. The sheet membrane retarder, ASTM E1745, and you can get several different grades of sheet membrane under that standard. It's rated by class A, B, and C. That relates to both the permeance of the vapor retarder and the physical strength, mostly having to do with puncture resistance for the membrane. One of the things...
And also whether or not it will disappear underground, like sometimes polyethylene has been known to do.
Really? And do you think that a 6 mil poly is going to withstand that iron worker traipsing across it, carrying the rebar?
No, I don't think so. I don't think
dropping a few, setting his chairs, and actually remain viable to perform as a vapor retarder. And that's why we've moved to some of these other sheet membranes, the high-density polyethylene mostly.
David, we had a question from Douglas about what's your opinion about using, Douglas Freeman, about using sand instead of stone?
Sand instead of stone? It's not coarse enough as a break between the substrate and the floor slab. It might give you a little bit better, or seemingly a better bearing surface for the concrete, but the concrete's going to fill the coarse voids of the stone, so it really doesn't matter much. Better to have those open voids to get that capillary break that Lewis mentioned. And ACI is, over the years has promoted the use of sand, but usually above the vapor retarder, and they've abandoned that. So the diagram that I have on the screen today is actually the preferred method from ACI now. The ASTM standard for the sheet membrane also comes with a companion standard for installation. And believe it or not, it actually tells you things like you should tape or seal the joints, that you should seal the penetrations to the membrane, so make sure that the membrane is actually continuous and doing the job. Let it vent near the perimeter of the installation, turn it up so that you create that complete enclosure under the slab. And just remember, once we get into the elevated slabs off of the grade, the metal deck really does turn into your vapor retarder. Sheet metal is a great vapor retarder.
Well, actually, sheet metal is a vapor barrier, true vapor barrier, but it does have joints in it.
It does, but who's counting those joints?
Can be a lot of lineal feet, but for our purposes, that's probably not a major source of vapor diffusion.
Because here's the rub on that if it's interior, if it's inside the building, and the temperature is the same above and below, there's no vapor drive.
And the relative humidity is going to be within a couple of percentage points of the same, unless you have a natatorium or some other high humidity area.
Right. So there's no vapor drive, so we don't have to worry about it.
Okay.
If you wanted to really get carried away, seal all the joints. Some of those sealant manufacturers would love you. Okay. Concrete. Here is probably one of the biggest contributors to this problem, concrete, because we're putting all of our flooring on top of it, yet we're throwing all the water into the mix and expecting it not to come out and not to cause problems with the flooring. And literally half of the water that we're putting in the concrete is just purely for convenience, so we can move the concrete, so we can finish it, so that we can get the concrete out of the truck. So we need to be careful of the water cement ratio, we need to be looking at keeping that down to the low 0.45 or less. 0.4 to 0.45 was what ACI is recommending. But some of the other things that we're doing to the concrete are really causing more of the problem. Lightweight aggregate. It's porous. It absorbs water. Gosh, when you mix it with the rest of the concrete ingredients, oftentimes it's pre-wetted to make sure that it doesn't overly absorb the cement paste and cause problems with the bonding and the curing. Fly ash and slag. Really fine particles that take a whole lot more water to wet them, because the surfaces, or because the particles are so small. And fly ash and slag have already been shown to delay the cure. So what might normally take, I hesitate to even say 30 days to cure concrete, but if we could truly get the concrete to cure in 30 days, fly ash and slag could extend it to 6 months or beyond, depending upon the percentage of fly ash and slag that you're adding to the mix. And I'm sure, Lewis, you
Yes.
never work on a project with fast track schedule, do you?
Essentially all of them. That's one of the major problems with this whole issue, is that everybody wants everything done very, very quickly, but as long as we're building with concrete, there are some built-in time periods that cannot be shortened in any practical way.
Correct. And I can't tell you the last project that was actually not fast track that we've worked on. I mean, it seems like everybody is in a gigantic rush to get everything built. So now that we have all the water in the concrete, we're going to put impervious flooring over it and expect the water to magically find its way out of this concrete slab without causing problems. So the flooring can be any number of things, and I have probably the one that might be least obvious on top here, the carpet. Because when you're buying carpet, especially for glue down installation, a lot of the backings on that carpet, the cushion type backings, are virtually impervious. You're putting them on there to make the carpeting more comfortable, the flooring more comfortable, give the carpet a little bit better life, but it's also making that carpet virtually impervious to the vapor and the moisture in the concrete floor.
It's kind of analogous to putting vinyl wall covering on the exterior walls in motels and hotels down here in the sweet sunny South.
Right.
And we all know what that causes.
Right. And anything that's a sheet rubber, sheet vinyl, gosh, and we can even see problems with tile. It's usually not as bad with the tile because you have more joints where vapor can actually escape. But the kinds of things you may see with tile is if we have re-emulsified adhesives, the adhesives can begin oozing up through those joints and cause a real mess for the finished floor.
Let's talk about that just a minute, and the difference, the changes in requirements for adhesives and setting mortars for tile that have we've gotten into because of VOC issues.
Yes?
That's a cue.
I thought you were going to carry that one through.
Well, just that in the old days when we were able to use solvent-based adhesives, a lot of these things were not issues because they were not affected by water. So moisture could come up and it would stop at that level of adhesive, which itself was impervious and was not an issue. But now that because of indoor air quality issues and having to use adhesives with reduced VOC content, obviously we need those things, being water-based, are water vulnerable, and that's, of course, the whole reason for this presentation today.
Right, and once you stop the water with this impervious floor, keep the moisture in the concrete, it's got to go somewhere. Eventually, it's going to equalize or reach equilibrium in the slab, and there's going to be a high water content near the slab, and you're going to have vapor trying to get out, and it will re-emulsify those water-based adhesives, and that's where the problems start.
Dave, we have a couple of questions and comments that I'd like to get caught up on. Evan Adams asked about the difference between sand above and below the vapor barrier. And Evan, we're going to kind of put that off, and similar discussions about compaction from question about compaction from Mark Schmidt, because that's really kind of a sidebar to our discussion today, and we want to get on to the main thing. But those are important questions. Evan also points out that fly ash and slag can have repercussions with regard to compatibility with curing compounds and dissipation.
Yes,
and
absolutely.
Hank Bruflot points out that concrete surfaces pH 12 plus, but adhesives are 9 to 10. And Sheldon says, well, what is the environmental impact of not using the old mastic adhesives after considering that floors are replaced when the adhesive fails? And of course, that's a strategic level question.
Yeah, great question, Sheldon. So we're using all the water-based adhesives in place of the solvent base, and now we're creating more problems. And yes, how do you even weigh that, except that by law you can't use the solvent-based adhesives anymore? But hey, Evan, I am glad that you're on board today. You said that you may not be able to make it, so thanks for joining us. And one of the last things before we really dive into the meat of this presentation, just wanted to touch on some of the mitigation products or methods that have been employed recently. And the manufacturers are out there, I know, scrambling, trying to find a real, the panacea type solution to this problem. And I don't know that there really is one yet. But what we're seeing happening is manufacturers promoting the use of epoxy coatings, in essence a primer underneath the finished floor that's applied to the top surface of the concrete. We've seen some silicate compounds being promoted, both as topical and admix applications. And there's been some pushback from the flooring industry. I've been having some discussions recently with a group called Install, which trains finished flooring installers, and they're working on an ANSI standard that actually is going to be promoting some of the correct installation methods for finished flooring. And this ANSI standard is going to prohibit the use of silicate compounds. The rationale is that the silicates can be left as a deposit on the concrete surface, and guess what? Just like the adhesives, the silicate compounds are also water soluble. So if they're interrupting the bond between the adhesives and the floor slab and they're soluble, once that vapor drive starts, the bond between that adhesive and the substrate could really be suspect. We've seen some polymer compounds promoted as an overlay for the concrete, and there's some advantage to this. There are certain areas of the country, and I'm in one of them, where the concrete finishing is not always the best. So you may find that some of these polymer compounds might be a good solution, because it's a good way to get a better surface on your concrete to work with and solve the moisture problem at the same time. We've seen some crystalline waterproofing, usually as an admix, and then there's some new compounds out there, hydrophobic compounds, that are just coming onto the market, and there hasn't been any substantial information available about them, and there are only a couple of people doing these at the moment. I have some hope that these kinds of compounds as an admix may be part of the solution.
Dave, we have a couple more comments from the floor.
Sure.
Jason Spangler asks, I think kind of rhetorically, what would happen if we had realistic construction schedules giving a realistic time for the slab to dry? And my tongue-in-cheek answer to that is we might get more realistic architectural fees, but that's...
You wish...
That's sore point. Hank Brufloat, says topically applied ilicates are expected to react with calcium hydroxide, but it's hard to tell if you're adding too much or too little.
That's correct, and what he means is actually silicates. There is missing an S.
Oh, well, okay.
So yeah, there are a number of silicate products.
Yes.
Potassium silicate, lithium silicate, sodium silicate. They're all a salt compound. And you're absolutely right that if you put it on the surface, the idea is you brush it in, you let it penetrate the concrete slab, but if there's too much, it's going to form a deposit on the surface. If there's too little, it may not do the job. Yeah,
some of the sealer hardeners have silicates in them, the
right.
Ashford formula and so forth. Steve Groth says, I actually met earlier this week with a product rep addressing the specific issue of moisture in concrete. The product he represented is Aridus Rapid Drying Concrete. He explained that the ARDC is a patented mix with a specialized admixture that allows them to match the water content of the concrete mix to only that which is consumed in the curing of the concrete. Interesting. No excess moisture is left that needs to evaporate or dissipate out of the concrete, avoiding typical moisture-related problems. The mix still works like a normal concrete mix when placed. Sounds like a good idea. Do you have any experience with this, and does it really work?
No experience with it, that's for sure, and I did not know about the Aridus product. What I can imagine, Lewis, though, is you specifying this kind of a product and then being required to get your cowboy hat and pack your 6 guns out on that construction site to make sure that nobody pulls that valve and adds water to that concrete truck.
Yes, actually, I do have a cowboy hat, but I usually carry a Glock 19.
Well, that could work too. But the monitoring of that on the construction site has got to be, it just has to be brutally enforced, I'm thinking, because it's been so common to be adding water to the truck before it ever gets out of the truck.
Yeah, and like you say, if you're not on the site, that will happen. Paul Gerbers writes, osmotic pressures can cause flooring failures even when the water table is 1,000 feet below, as in Arizona, when the water reacts with alkali salts on the surface, on the slab-on-grade surface. And let's see, Evan Adams again says Aridus is marketed by Stego reps but made by U.S. Concrete. ACI has done extensive studies on self-desiccating concrete. Roland Vieira says, I have had lab experience with the Aridus product, and yes, it does work. Interesting. Hank Brufloat writes, ACI suggests that concrete drying time is 1 inch thickness per month at 70 degrees at 40% relative humidity with a 15-mile-an-hour wind. Drying time is a long time. Hydration takes time. That's just, and we really can't. Yes, with conventional methods, that's just a built-in delay that you can't get around.
Well, and think about that. I mean, the conditions for drying at that rate has got to presume that the building is enclosed, because it's the only way that you could maintain those kinds of conditions. And then you're going to have to introduce fans to get your 15-mile-an-hour wind, of course. but you're going to have desiccant drying or some sort of dehumidification to get the moisture out of the building as all the moisture is released from all the construction materials.
Oh, and Steve Groff has a follow-up comment on the Aridus, saying that they work with specially trained installers. They send their own people to the site to monitor installation, so water added should not be a concern.
Okay, and that came from Steve. Steve, do you know where Aridus is based out of? If you do, just jot that down as one of your comments, because I'm just not familiar with them. I think it may be something also of the hydrophobic kinds of compounds as admixes that we're seeing, and I'm familiar with another company, I believe it's Highcrete, that is offering that kind of a product. And Highcrete's here in New Jersey, and Evan tells us Aridus is in San Jose, California. Thank you, Evan. All right, so one of the things that we need to do, just pressing on here, because I want to get through what I'm seeing being done to try to combat this whole moisture issue, is testing, number one. And testing can be done by any number of people, and currently the guide specifications that are out there are really specifying testing in each individual finished flooring spec, and it's tending to become such a problem that I think assigning it to individual flooring specs and expecting a subcontractor to perform his own testing is going to become more and more problematic. One thing it does is it eliminates any possibility of any correction because you aren't going to know until just before the floor is installed that you really do have a problem. So we have the calcium chloride test. That's been a tried and true test. And until recently, the flooring manufacturers have really relied on that. Just recently, they're tending to move more towards the relative humidity test. And you can see the limits I have here. The calcium chloride was measured in pounds per 1,000 square feet in 24 hours. In relative humidity, most of the manufacturers are pushing the allowable humidity upward. It was at 75% for those that were allowing it, and it's creeping up to 80% for some. And someone had mentioned on the comments before the pH testing, looking to get a range of 7 to 9 for the concrete surface before you put down these water-based adhesives. Now, freshly placed concrete is a pH of 13, which is a huge difference from 7 to 9. So here's a typical calcium chloride moisture test.
David,
Yeah.
Roland suggests that to gain the very best picture of moisture conditions of the slab, both tests should be run concurrently.
You can. There will be, and you'll get different data because the two have no way to be correlated. So you have to be careful, because if you do run both and one of them happens to pass and the other doesn't, I guess you would have to have some way to determine that either both have to pass to be able to install a floor. So calcium chloride test, it's not an expensive kit. Okay? And there are the basic pieces. You're going to have a scale. You're going to weigh the calcium chloride container on the scale. You're going to have a plastic cover. You're going to open the container. You're going to seal the cover down to the floor. And you're going to wait. And pray that none of the construction workers come by and kick the cover, step on the cover, break the plastic, because all of that's possible. You're testing. The first group of tests is 3 tests for the first 1,000 square feet, and then 1 test for each 1,000 after that. So you're going to have a good number of tests going on. And let's see if this is actually going to work.
While we're waiting for that to come up, Hank Brufloat says F2170 measures available humidity and is a static measure. F1869 measures volume over time and is a dynamic measure.
Okay, and I guess you're seeing the YouTube, is this correct?
Yes.
Yeah, excellent. So this gives you just a basic explanation of how the test is actually conducted. And some of the difficulty is you need to make sure that whomever's conducting the test actually does know the ASTM standard. Because if they don't know the standard and they conduct the test incorrectly, you're going to get bogus results. One of the things that happens during the test is exactly this. If the floor slab is not cleaned before you do the test, you're going to get inaccurate results. You need to remove whatever curing compounds, oils, dirt, dust from the concrete surface. Here you see them actually weighing out the calcium chloride container, marking it, opening it up, and another important part, this tape that actually seals the container must be saved, because remember, you weighed the container with the tape on, and you have to weigh it at the completion of the test also with the tape on. Okay.
Eric Lussier says that the standard F1869 actually says to lightly grind the surface to produce a surface profile. There's a specific level.
It does say that, but it's really easy to skip that step. And anybody that's out inspecting should see exactly what's going on in this film, because you can see the difference in the concrete surface color and texture because of the cleaning process.
Evan says, can anyone point to a peer-reviewed study on calcium chloride testing? Probably not. That grinding in the video is critical. It takes 3 visits, not 2. 99% of specs do not require 3 visits in grinding.
Okay, and I did mention Install, a group that I'm talking to, and they actually have certified installers. Now this is the pH test, and you can see that the number of pieces that you have are really pretty limited. Distilled or deionized water so that it's clean, no impurities in the water. A pH test strip. And is this going to give up on me? It is. pH test strip, and what you do is you wet the concrete slab, very minimal amount of water, and all you do is dip the pH test strip into this water.
And find out if your slab is pregnant or not.
Correct. Then we'll hope not. Eventually what you end up doing is, let me see if I can get this to scroll ahead and show anything. No, it's not going to cooperate. Alright, pressing on. You're going to take the pH strip and eventually compare it to a guide furnished by the pH strip manufacturer, and you're going to match color. So you're going to tell the pH by the color of the strip, and you're probably going to find the pH as tested is going to be something more than 9. And
Hank Brufloat points out that a pH meter is more accurate than the papers.
You can use a pH meter, you're absolutely right.
But more expensive.
More expensive, at least for the equipment. The pH test strip is a fairly easy test to conduct, and it for the purposes of the floor adhesives, it's probably accurate enough. Okay, so that the second YouTube video didn't work, so we'll have to try something else maybe differently next week. The surface prep What I'm looking at for our own projects is trying to get this as a dedicated subcontractor rather than trying to have each flooring subcontractor responsible for the surface prep. We're looking at mechanical cleaning, abrasive glass cleaning or shot glass cleaning. There is a standard that we can rely on, and we can also rely on the ICRI concrete surface profile standards to know whether or not the surface prep is close. Let me back up.
While we're waiting for that to come up, Hank points out that a pH meter is available. You can get one for about $100.
Okay.
So and John Latin again echoed your reminder that you have to use distilled water when using the strip.
Right, distilled or deionized water, either one. Now, I wanted to show this short video on blast tracking so you can see the size of the shot. It's really pretty small, but it does come in a variety of sizes. And all you do is dump the steel shot into the shot blaster. It's a self-contained unit. It's got a vacuum. So the amount of dust that's generated is pretty minute. Shouldn't cause major issues. It goes fairly quickly. You can get shot blasters in a variety of widths, up to, I think it's about 36 inches, and some of them are actually ride-on machines. So if you have large floor plates, you can do them pretty quickly. And in a single pass, you're getting the profile that you're looking for the final finished flooring installation. So you can see it does go fairly quickly. And self-contained, you can see there's virtually no dust being generated with the vacuum attachment.
Robert Bowman asked, does broom finished concrete dry faster than float finished? Is this a strategy to employ? And I don't know that I've ever thought about that. I don't think it makes a difference. I don't think there's enough difference in the surface area from the rougher texture to make a significant difference in the time of hydration.
Well,
perhaps somebody else knows more about it than I.
Here's some of the concern there, and I don't know that it makes a difference in the curing or the drying of concrete, but if you think about it, if we're going to mechanically prep the floor slab and we spend all the money to do a really good hard steel trowel finish and then take the surface off, are we spending our money wisely? Because here you can see the surface prep. These are right out of the ICRI rubber molds that you can buy to show you.
That's an interesting thought. That maybe we should go just for wood float rather than the slick steel trowel for the surfaces that are going to receive subsequent finished flooring.
And that's a possibility.
Robert Bowman has a couple of comments, and Hank. Robert says, does broom finish Hank says, diamond grinding profiles very well and leaves a smoother surface and requires less cement compound. Jason Spangler says they're actually looking at that right now. The thought is that we are over-troweling and over-densifying the surface and impeding the drying process. So maybe there is a way to actually reduce the time of hydration.
Right, and there are all kinds of finishes that you can apply to the floor. So, I mean, steel trowel has certainly been the traditional, but it's if it could be shown that by not steel troweling that we get a better moisture condition in the slab, that would be something certainly worth looking at. And that's not something that I've investigated, so I don't know what that result is. But I'm looking at going to the shot blast finish, and it's a shame to pay for good, like double steel trowel hard finishes.
We have a couple comments on that. Hank points out that a hard steel trowel surface can act like a surface vapor retarder, but it is difficult to bond adhesives to. And Evan, yes? Evan states the proper way to spec the surface is a single pass with a steel trowel to produce a smooth finish without an overly dense layer that may inhibit drying or be used to hide future curing.
Okay. That sounds like another site monitoring. Evan, we need you to volunteer. All right. So back to the ICRI profiles. All of these profiles are available. You can buy rubber molds that show for visual acceptance.
Comparison.
Yes. To know that you're close. And you can't really specify and get a CSP 3 and expect that it's going to be exactly 3. Really ought to be looking at a range. And the different floor finishes will require a different range. The thin film, like paints and some of the very thin film coatings, you ought to keep it as light a profile as you can. The 3 is probably ideal for those thin films.
I think one of the photos has a rather rude subliminal picture in it, but we won't discuss that on the air.
Oh, really? Okay. I'm not going there, Lois. All right. What I am actually proposing to some of our clients is, and we're hearing this also from some of the flooring subcontractors and the flooring manufacturers, that there needs to be a way to accommodate all of these issues with the floor moisture. And one of the things that we're looking for is trying to see if we can bring some of the testing, the surface prep, and if we need mitigation, the mitigation to a single source. And whether that's a specialized subcontractor, whether it's the contractor or construction manager, but pulling it out of the responsibility of each of the different half a dozen finished flooring installers, so that we get a uniform approach for the entire project. What we're looking at is a separate specification for both testing and for surface prep, so that we can set the requirements once for the entire project, and then within the finished flooring sections just simply reference back to those surface prep and testing sections.
A couple of comments on the tweet side, David. Paul Gerber points out that the CSP3 is difficult to achieve, and it may be more practical to specify a range. And then Eric Lucier says, we have lost projects over a few $100s. It is hard to carry any additional testing or preparation money on a project.
Right, and that's one of the reasons why I'm suggesting that perhaps the way to do this is to pull it out as a separate item. And you can see here what I'm suggesting too is perhaps the use of an allowance or a unit price for the mitigation, especially, because it's one of those things where if everything goes right and your slab is within the allowable moisture content, you don't need it. And if you've captured the price, there's no surprise to the owner if you do need it. There's no surprise to the contractor or design team because he already knows what the solution is. Personally, my struggle with all of this has been that I'm now specifying a fix for a problem that I don't know is necessarily going to exist. And building that cost into a project, to me, sort of goes counter to what you're trying to do through competitive bidding. But I think if we can approach it as an allowance or a unit price and then apply it only when needed, I think we're going to actually be doing the project a better service.
That makes a lot of sense, because even on a single project, conditions from one end of the building to the other could differ widely.
Right, absolutely. So,
just to back up a little bit, Lloyd Miller asks, how do curing compounds play into all of this?
well, if we use actual compounds that are essentially a film-forming compound, which is what ACI wants us to do, that the first thing you have to do is remove them, because none of the flooring adhesive manufacturers want to bond to the curing compound, because they don't know, number one, they don't know what it is, and they don't know if the bond is going to be acceptable between their adhesive and that curing compound, and then between the curing compound and the concrete.
And do dissipating curing compounds always fully dissipate? And most of those break down in UV, and if you have a building with supporting floors, the shaded areas may not lose the curing compound as well as the areas that are exposed to sunlight.
Right. And here's one of the other humidity tests, the RH test. And this is done simply by boring a hole in the concrete, inserting a sleeve, and then coming back with an instrument to read that RH at 40% of the slab depth. This still takes multiple trips. You still have to clean the slab, you still have to drill the hole, you have to insert the sleeve, you have to let the sleeve acclimate, the atmosphere inside the sleeve acclimate, and come back and read the test later. So just like calcium chloride, it's not a once and done deal. You're making several trips to the site to accomplish it. Okay, so let's look at some of the problems. We had one of our group members, Kime, had submitted some information about a recent project. His is on the right-hand side, and a recent project from our archives, it's actually under construction as we speak, is on the left. So Kime is reporting that in his particular case, the spec didn't require testing, but the product data for the finished flooring that the contractor submitted did require testing.
In other words, the manufacturer's installation instructions.
Right, did require the testing. But because it wasn't in the spec, no testing was done. So the floor tile was installed, and now they're having adhesive problems. So what happens? How can we possibly resolve all of this? You know, the subcontractor was looking at the spec and saying, because it wasn't specified, he didn't price it, it wasn't included, you know, he's not responsible. The GC is saying, well, the manufacturer's literature requires it, and you're required to follow the manufacturer's instructions because in effect they govern the installation. It's not black and white, and if it's not in the spec, it may not be enforceable because manufacturer's instructions are not contract documents. The submittal is not necessarily a contract document, at least under AIA rules. If you're under CONDOC, a different set of rules, and then submittals do become contract documents. So you need to know what the rules are and how they're applying to your particular project. What you really want to do is avoid these arguments after the failure happens, especially. So let's take a look at the project where I have a little bit of data to actually report. This was an academic project for a university, Western Pennsylvania. It was 4 floors, slab on grade, 3 elevated slabs. The moisture tests were just conducted. They took a total 14 moisture tests, 5 at slab on grade, and you can see the results. 91%, ranging up to almost 99%. Specified RH was 75% to be able to install finished flooring. So let's take one step in closer and look at the project conditions. Remember, 91 to 99% RH measured. These slabs were poured almost a year ago. So they've cured more than the 28 days. The project really wasn't enclosed until September this year. They did use normal weight for the concrete slabs, for the slab on grade. The elevated slabs were lightweight concrete, and both had fly ash. Now, the building was enclosed before Sandy passed through Pennsylvania, so they didn't get all of that water. But it was exposed to rain during the course of construction. So until this building is enclosed, I think the data here from this one project sort of points to the fact that you absolutely must be able to enclose that building, and you have to be able to drive that moisture out of the concrete, and the only way to do that is to start running the HVAC system. Start putting the building almost at operating conditions. You have to remove the moisture from the atmosphere around the slab, or you're never going to get the water out of the slab. And in effect, I think that that's what's happening here. Now, as a result, in this particular case, they're looking at about a $90,000 add to take care of the moisture mitigation product, and in this case it was an epoxy thin film primer to go over all the concrete slabs. So it's not a small amount, and $90,000 is certainly enough to grab the owner's attention. And it in the case, I think it was Eric was saying that in a couple $100 can make a difference between winning and losing a project. The subcontractors, the installers, are not going to want to bet on whether or not this slab that the GC and the concrete installer is going to meet the actual required test conditions. So, where do we go?
Well, we kind of need to get caught up with some comments and questions, although we're fast running out of time. Let's see. Alex, well, let's back up. Roland Vieira says a re-wet slab can require upwards of 3 times the normal drying time. The slab does not begin to dry until serviceable conditions until full enclosure is achieved. Alex Dittenhofer says that in the field it still seems like people are trying to hide behind concrete moisture issues. It's very rare to find a concrete slab that reads below 3 pounds, and yet of all the carpet glue and epoxy, people say that if the concrete is 3 pounds or above, then you need a moisture mitigation system. Shouldn't a moisture mitigation system just be standard practice?
Well, and that's where I think we're going. But what I don't want to do is add the moisture mitigation as standard practice, have the owner pay for it, and then not have it used. If, for some miracle, the slab will actually meet the moisture requirements. And that's one of the reasons I'm suggesting that the way to deal with it is either through an allowance or a unit price.
Lloyd Miller asks what criteria are used to determine which sections of the slab on grade are tested and which are not tested. Should the entire slab on grade be tested if testing is to be required?
Well, the testing is really all about the floor finish. So if you have impervious flooring over the entire slab, yes, you should be testing the entire slab. If you have it only over a portion, can you get away with testing only those portions of the slab by the ASTM standards and by the floor finish manufacturers? Probably. Is it a good idea? I can't say. It's going to depend upon the configuration of the building, what other floor finishes you have, what the spaces are, what you're expecting out of the slab. But the tests are not all that expensive, and there aren't going to be that many to begin with. If you're talking about 1 per 1,000 square feet, 20,000 square foot building or 20,000 square foot floor plate, you're talking about 20 plus the 2 additional for the first 1,000. So your 22 tests to cover the floor. And the calcium chloride, just as an indicator, we were looking at what, $13 for the test kit by 22, which is not a tremendous amount of money for the test itself. And then just the labor, and the labor, they can certainly come back and read all those tests in half a day or less once they have the testing installed.
There's a couple of comments that I want to read, and then we're just about on the verge of wrapping up. Edward Depwin says, our solution has been to inform the owner of the potential issue, require slab testing, and obtain unit pricing on moisture mitigation during bidding. Then if we have an issue determined by testing, we already have a unit price in hand. And of course that's along the lines that David is suggesting. Evan Adams says that there is a position paper from the flooring contractors, concrete contractors, and wood floor contractors on the fix for curling should be an allowance. You could have the same allowance section deal with mitigation.
I wasn't even aware of the recommended for curling. Okay, thanks.
Wade Bevier asked the question, what is your opinion regarding initial placement of a 2-part system with a topping slab that is both a leveling and moisture controlling layer to be installed as part of the initial pour?
Wade, I'm familiar with at least one manufacturer that's promoting that kind of solution, and actually their promotion for it is that if you're doing an epoxy primer, in essence, as your vapor control and then a topping over it, that really what you're doing is you're relying on the topping to protect that vapor control layer, such that if ever you do have to replace the finished flooring, that you're not damaging the vapor control. You can simply damage the surface of the topping layer. You can flash patch that back in and reinstall new flooring. There's some benefit to that, I suppose, if you're planning on keeping the building for a very long time and you know that you've selected a material that's going to eventually need to be replaced. Keeping yourself out of damaging that moisture protection is probably a good thing.
We really are out of time, unfortunately. One of our participants has suggested that we might want to continue this discussion at a future date, but I want to give you time, David. David has kindly consented to provide a couple of sample specification sections to the audience. And David, you want to tell us about those and how they can get those?
Sure. We wrote the testing and the surface prep spec sections as separate sections, and anybody that is interested in having them, I'm happy to provide them. They're Word documents. You can use them as you wish on your project. If you want them, I would love dearly to hear your comments about them. I know several of the folks on the call here have already requested them because of a blog posting I made. All you need to do is just email me, and I will make certain that you get copies of the documents for your use. But please share your comments. I would love to hear it. If you have a better solution for what we're trying to do, I would love to hear that too, because right now the industry is struggling trying to figure out how to deal with this problem. And you can see from just the recent example, we still don't have a good solution. We know that it's an ongoing problem, and there is no real firm, good solution today.
Okay. Well, saying goodbye from Nashville, this is Lewis.
And this is Dave from Southern New Jersey. Look forward to having you join us next month.
Great. Well, thank you, everybody. You all have a good day, and you can disconnect now.